Good morning, everyone. Let us start this session. So, in the previous session, we started with the wage friction, and we have solved one problem on the wage friction. So, note down the next problem. So, this is the question from university question paper. So, refer this problem. So, question is find the force F to have the motion of the block A impending up the plane. Take the coefficient of friction for all the surfaces in contact as a 0.2. Consider the wedge B is weightless. So this is the given condition. So here we have one block A. So it is having the weight 200 Newton. And it is supported by the wedge B, and we are applying the force F, okay, in this direction. So the impending motion required for the block A, it is along this direction, up the plane, okay. So this block A, it is supported by this wall, which is inclined at an angle 75 degree. Okay, so here we have to find out the force F required to cause the motion of block A up the plane. Okay, so this is the required motion. So to solve this problem, your first step will be we have to draw the free body diagram. Okay. So for the free body diagram, we will isolate the block A from the wedge B. So this is the block A. Now on the block A, the first force, it is the weight force. So it is given here. This is 200 Newton. So it will act exactly in the downward direction. So it is vertically downward. So this is 200 Newton. Okay. Second force is the normal reaction. So this block A is supported by this inclined wall. So this wall will offer the normal reaction. You can observe here. The normal reaction will be like this. So this reaction will be exactly perpendicular to the contact surface. So we will show the normal reaction here in this direction. And this reaction is perpendicular to this contact surface. So let us take this reaction as N1. There is a second normal reaction at this contact surface. The contact surface between block A and wedge B. So this reaction at this contact surface will be like this. And it is exactly perpendicular to the contact surface. So you can show that reaction here. So actually this reaction is a common reaction. So this reaction we will consider as N2. And it is perpendicular to the contact surface. Now we have to show the friction force. So friction force will be at this contact surface and at this contact surface. So we have to decide what is the direction of the impending motion. So when we apply the force F in this direction, that is along the negative x direction, wedge B, it will slide in this direction. And due to this, the block A, it will slide in the upward direction. So the friction force at this contact surface, it will be in this direction, opposite to the impending motion. So first, show the impending motion direction. So this is the impending motion of the plane. Friction force will be in the opposite direction to the impending motion, and it is tangential to the contact surface. So this is the friction force, and its value will be the general formula for the limiting friction. F max is equal to mu s into normal reaction. So mu s is given as a 0.2 for all the contact surface. So mu s, this is equal to 0.2 into normal reaction n. So this is the friction force. So this is 0.2 into n1 because this is normal reaction. Now observe the friction force at this contact surface. So when the wedge B is sliding in this direction, this contact surface, it will slide in the opposite direction to the motion of the wedge B. So for this contact surface, impending motion like this. So at this contact surface, we can show the impending motion direction like this. So actually this is a relative motion. So when the wedge B is moving on the left side, then the block A, it will move on the right side relative to wedge B. Now you can show the friction force exactly opposite to the impending motion. So this is the friction force at this contact surface. So this value of friction force, this is equal to 0.2 into normal reaction N2. So here we have shown all the forces. Now next step is we have to resolve the forces. So for the resolution, you can assume this vertical direction as a y direction, and this is the x direction. So this is your reference axis. So try to resolve the forces along this direction. So this 200 Newton, it is exactly along the y direction. So no need to resolve this force. But remaining forces we have to resolve. So out of that, we will consider the N1. So N1, draw one component parallel to x-axis and draw this component parallel to y-axis. Now this angle, so we can find out this angle. Just observe this. N1 is perpendicular to this contact surface. Just I will draw it here. This is 75° given, and this is the N1. So this is 75, this is 90. So remaining angle will be 90 minus 75. So it is 15°. So this angle, this is 15°. So x component will be N1 cos 15, and this is N1 sin 15. Now this point to N1, it is also inclined to x or y axis. So we should resolve this force. So we can resolve this force by considering a point on its line of action. So draw one component parallel to y axis, and this component is parallel to x axis. Now this angle, or this angle we can find out. So this angle will be 75 degree. Just observe this geometry. So this is your friction force. So if you draw one line like this, so it will be parallel to this line. Okay. So this angle is 75. So this will be alternate angle. So this is 75. Now you can write the component. This is 0.2 N1 cos 75, and this component will be 0.2 N1 sin 75. Next, we have to resolve this N2. So for that, select this point, draw one component parallel to x-axis, second component parallel to y-axis. Now we have to find out the angle. So for that, observe this angle. This is 15, and here this vector is perpendicular. So this is 90. So this remaining angle will be 90 minus 15. So this will be 75 degree. So this is 75 degree. So x component will be N2 cos 75, and this y component will be N2 sin 75. Now resolve this point to N2, that is a friction force. So select this point, draw one component parallel to y-axis, second component parallel to x-axis. Now this angle, it is 15. So you can observe here. Friction force, it acts along this plane. And this is the x component. And this is the y component. So this angle, this is 15. And therefore, this line is parallel to this horizontal line. So this angle will be 15 because it is an alternate angle. So therefore, this angle is 15. Now, y component is the opposite component. So it is 0.2 N2 sin 15. And this x component, this is 0.2 N2 cos 15. So here we have resolved all the forces along this reference x-axis and reference y-axis. So after this, you can draw the free body diagram for the wedge. So draw the second free body diagram just below the first free body diagram, because this N2 reaction is common reaction. So this is common reaction N2. Just direction is opposite. This reaction N2 will be perpendicular to the contact surface. Next, we have the reaction offered by the ground to the wedge B. So that reaction we can consider as a N3. So this is the normal reaction N3. Then we have the external force, which is F. Now the impending motion for the wedge, it is along the negative x direction. So this impending motion. As the impending motion is along negative x direction, so at this contact surface, the friction force, it will be opposite to the impending motion. So this is the friction force, and this value is, coefficient of friction is 0.2, normal reaction is N3, 0.2 N3. Similarly, at this contact surface, the impending motion is same. The complete wedge B is moving towards the left side. So at this contact surface, friction will be like this. it is along the plane and opposite to the impending motion. So this value is 0.2 and this is normal reaction N2. So just observe this friction force is exactly opposite to this friction force because it is the common contact and it is a weightless, that is the wedge B. So we will not consider the weight of the wedge. Now just we have to resolve the forces by taking this reference. So first we will resolve the N2. So for the N2, draw one line parallel to x-axis and this is the parallel to y-axis. Now you can observe here we have taken this 75, so definitely this will be 75. So this component is N2 cos 75 and this component is N2 sin 75. Next, resolve the point to N2. So select this point. This is the y component and this is the x component. This small angle, it is 15 degree. So this component will be 0.2 N2 cos 15 and this y component is 0.2 N2 sin 15. Next, this point to N3, it is along the x-axis, no need to resolve. N3 is along the y-axis and this F force, which is to be determined, it is along the x-axis. So this is complete free body diagram for the wedge B. Now when we use the condition of equilibrium, consider this FBD first, FBD of the block A, because it is having only two unknowns. One is normal reaction N1 and second is N2. But for the wedge, we have three unknowns F, N3 and N2 and we just have two conditions. So for the calculation, consider the block A first, use the condition of equilibrium. So your first condition, summation fx is equal to 0. So for summation fx, consider all x component. So starting from this n1 cos 15. Then we have this point to n1 cos 75. Then this is negative n2 cos 75. So minus n2 cos 75. Then we have this component of friction force. It is also negative. So minus 0.2 n2 cos 15. And this is equal to 0. So from this you can take n1 common. So try to find out the coefficient of the n1. So this value is 1.02 n1 and minus 0.45 n2. This is equal to 0. So take this equation 1. Next, use summation fy is equal to 0. So for summation fy, consider all the y components. So consider this n1 sin 15. So it is plus Next, this 0.2 n1 sine 75, it is minus, so minus 0.2 n1 sine 75. Then we have this component n2 sine 75, it is plus. Then this component of the friction force minus 0.2 n2 sine 15. Then this self weight 200 Newton, so minus 200, and this is equal to 0. So take this n1 common and find out the coefficient. So this value is 0.065 n1 plus 0.91914 n2, this is equal to 200. So this is your second equation. Now solve the equation 1 and equation 2 simultaneously. So you can use the equation mode. So you will get the first value, normal reaction N1 as 93.6 Newton, and the normal reaction N2, this value is 212.16 Newton. So actually we need this value because it is the common reaction. Now consider the free body diagram for the wedge. Now again use the conditions of equilibrium. So summation fx0. So for the summation fx0, this is the x component. So it is 0.2 n2 cos 15. Then 0.2 n3. And there is one more component, which is n2 cos 75. And minus f, it is on the negative side. So minus f, this is equal to 0. So in this equation, you can take this common n2 and can get the coefficient. Sorry, n2 is known, so just put the value of n2. So you will get the equation 0.2 n3 minus f plus 95.89. This is equal to 0. Just put the value of n2 in this equation. Okay. Next, use summation fy is equal to 0. So for the summation fy, this into sine 75 on the downward direction. So it is negative y direction. So minus into sine 75, this 0.2 into, so plus 0.2 into sine 15, this n3, so plus n3. So only three components. This is equal to 6. From this equation, you can calculate the value of n3. Put the value of n2. So from this equation, the normal reaction n3, this is equal to 193.95 Newton. Now put this value in this equation, and then you will get the value of F. So that equation will be, if you write F, this is equal to 0.2 n3 plus 95.89. Just put the value of n3. So it is 0.2 into 193.95 plus 95.89. So finally, you will get the answer as 134.68 Newton. Okay, so this is the required value of the force F on the wedge B, so that the impending motion for the block will be in the upward direction. So question was, find the force F to have the motion of the block A impending up the plane. So if you apply the force, which is equal to 134.68 Newton, then the given system will be on the verge of motion, and the motion will be impending up the plane. So this is your final answer. So in this way, you can solve the problem on the wedge friction. Note down the next problem. So take this problem as a homework. So here, one block of 500 Newton is supported by another block of 1000 Newton. So this block A, it is having the weight 500 Newton. The block B, it is having the weight 1000 Newton. This angle, that is a tapered angle, this is 60 degree. And force P, it is applied on the block B exactly in the horizontal direction. So the coefficient of friction is 0.25 at the floor. So here friction is 0.25. This is static friction. 0.3 at the wall. and 0.2 between the blocks. So at this contact surface, friction is 0.2. So we have to find out the minimum value of the force P, which is applied to the lower block, that will hold the system in equilibrium. So what is the minimum value of the force P, so that the equilibrium is maintained? So for that, to find out the P minimum, we have to decide the impending motion. And after that, you can draw the free body diagram depending on the impending motion. So try to solve this problem as a homework. Just you can note down the answer for the P minimum. It is 81.02 Newton. So if we apply this much force, 81.02 Newton, on the block B, then it will maintain the equilibrium. If the force drops below this 81.02 Newton, just imagine we apply the force 79 Newton. Then at the 79 Newton, what is the impending motion? Definitely there will not be equilibrium. So there must be some motion. So if there is a motion, then what is the direction for the block A and direction of the block B? Then you can decide the direction for the friction force. So first step in this problem is we have to decide the direction of the impending motion for P is equal to P mean. Okay, and then draw the free body diagram.